Once again, hearty welcome to the Math Revision Made Meticulous video series. Topic: Continuity and Differentiability. Differentiation of implicit functions. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per video from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answer. Before we go for this differentiation of implicit function, let us try to recollect rules of derivatives and formulae of differentiations. U and V are two real valued functions, then u plus or minus v the whole dash is u dash plus or minus v dash, and this is the product rule. U multiplied by v the whole dash is, keep the first, differentiate the second, keep the second, differentiate the first. U upon v, where v is not equal to 0, differentiation is v square, and numerator v into u dash minus u into v dash, that is denominator square, denominator into differentiation of the numerator minus numerator into differentiation of the denominator. Let us have a quick look at the formulae of differentiation. X power n, n into x power n minus 1, root x, 1 by 2 root x, e power x, e power x, a power x, a power x log a, log x, 1 by x, sin x, cos x minus sin x, tan x, secant square x, cosecant x minus cosecant x cot x, secant x tan x, cot x minus cosecant square, sin inverse 1 upon root 1 minus x square, cos inverse minus 1 upon root 1 minus x square, and tan inverse 1 upon 1 plus x square. Let us see what do you mean by explicit function before we go to have an idea about implicit. Suppose when a relationship between x and y is expressed in a way that it is easy to solve for y and write y is equal to f of x, we say that y is given as an explicit function. Very simple. Y is given as a function of x. Y is equal to f of x. We have seen a lot of examples. For example, sin inverse x, sin of tan inverse root x minus 1, log of x power 4 minus 2x, y is equal to secant tan of root x. What you are observing here? We are observing here y is in the left hand side and a function made up of x is on the right hand side. Y is expressed explicitly as a function of x. Let us move on to what do you mean by implicit, the other way. An implicit function is a function that is defined implicitly by an implicit equation by associating one of the variable with the other. It will be a mixture of x and y. Therefore, it will be denoted as f of x comma y is equal to 0. Now, you are seeing here x square plus xy plus y square is equal to 0. It is an implicit function. We are not able to express y is equal to f of x directly. This is another one. Sin square x plus cos square y is equal to 1. And y square plus tan square x plus 2xy is equal to 0. Now, you got an idea that what is the difference between implicit and explicit. In explicit function, we directly start the differentiation. Left hand side will be dy by dx, right hand side apply the formula straight away. But let us see what we have to do when you come across implicit function. For that, the rule is differentiate the implicit function using rules and formulae of differentiation. Collect the terms with dy by dx to left hand side and express dy by dx as an implicit function. Once again, the final answer will be most probably an implicit. In rare cases, it will become an explicit. Well, let us move on to an example. Before we go for that, we should know the chain rule, because here we are going to differentiate tan y, cos y, y square, xy, secant y, square root y, like that we will be differentiating them. What is the differentiation of y square? 2y into dy by dx using chain rule. What is the differentiation of sin y? Cos y into dy by dx. What is the differentiation of xy? Keep x, differentiate y, plus keep y, differentiate x. What is log y? 1 by y into dy by dx. This is very, very important. And tan xy, you see here I am using tan of something. Secant square xy into d by dx of xy. Once again, d by dx of xy already we know that. Just we have discussed. Suppose you have sin inverse of x square y. 1 upon root 1 minus that x square minus y whole square. And d by dx of x square y is keep x square, differentiate y, keep y, differentiate x square. Now this chain rule is very, very important whenever you are coming across implicit function involving y. Well, let us move on to a question. X square plus xy plus y square, just we have discussed. This is the implicit function. How to do it? Differentiate it totally. Differentiation of x square 2x. Then differentiation of xy, use chain rule, product rule, x into dy by dx plus y. Differentiation of y square is 2y into dy by dx. Collect all dy by dx, push everything to the right hand side. You got the answer. Very simple. Do it very carefully. Wherever y comes, when you differentiate, it is dy by dx. We are going to the next question. Sin square x plus tan square is equal to 1. Differentiation of sin square x is 2 sin x into differentiation of sin x. Differentiation of tan square y is 2 into tan y into differentiation of tan y. Differentiation of sin x is simply cos x, but differentiation of tan y is secant square y into dy by dx. Be careful. Now I have collected dy by dx. Well, after seeing these two examples, let us move on to some questions now. Question is xy plus y square is equal to tan x plus y. We have just seen that what you have to do, differentiate from left to right, collect all dy by dx and express the answer. Well, I differentiated now. What is xy? How to differentiate? Using product rule. X into differentiation of y plus y into differentiation of x is 1. Y square differentiation is 2y into dy by dx. Differentiation of tan x is secant square x. Differentiation of y is dy by dx. Collect all dy by dx to one side and express dy by dx as secant square x minus y upon x plus 2y minus 1. Simple. Let us move on to the next question. It is sin square y plus cos of xy is equal to k. Just to differentiate from left to right. What is the differentiation of sin square y? 2 sin y into differentiation of sin y minus cos xy differentiation is minus sin xy into differentiation of xy. What is the differentiation of sin y? It is cos y into dy by dx. The differentiation of xy, you have to use product rule. Keep x, differentiate y, plus keep y, differentiate x. Now collect all dy by dx to one side. Then push it. You will get the answer now. But dy by dx is y sin of xy by 2 sin y cos y minus x sin xy. Differentiate from left to right. Collect all dy by dx. Whenever y comes, be careful. It is dy by dx to be written over there. Okay. Now sometimes you will be asked to prove some result. Prove that dy by dx is so and so. This problem is a little bit interesting. You should not start directly. Let us see what you have to do. Some technique is there. I have written x into root 1 plus y is equal to minus y into root 1 plus x. I want to avoid the square root first, squaring both sides. I have avoided the square root now. Now I expand this bracket, x square plus x square y plus y square plus xy square. I bring everything to one side. Then after that, I am just going to do some meaning of taking factors outside, common term outside. Therefore, from first two term I take xy outside, I will get x minus y. Then from the second one I take x plus y outside, it will be x plus y into x minus y. All of you know, x square minus y square is x plus y into x minus y. Which can be taken outside? X minus y can be taken outside, but x minus y is non-zero. Therefore, you are getting only xy plus x plus y is equal to 0. Therefore, from this, what I am getting now? I am getting that y is equal to minus x upon 1 plus x. Highly interesting problem. Even though in the beginning when you see the original question, you think that it is a problem of implicit, but actually it is an explicit one. Well, directly differentiate and you have to use u by v form. Denominator whole square, denominator into differentiation of the numerator minus numerator x into differentiation of 1 by x. Therefore, I have differentiated. I got the final answer as minus 1 upon 1 plus x the whole square. And highly interesting, this problem final answer is explicit function. Well, let us move on to the next question. Sin of x plus y plus cos of x plus y is equal to 1. And one condition is given that tan of xy not equal to 1. You have to prove that dy by dx is minus y upon x. Let us start doing it now. Sin of xy. What is the formula? Cos of xy, differentiation of xy. Differentiation of cos xy minus sin xy into differentiation of xy. How to do differentiation of xy? Use uv form. X into differentiation of y plus y into differentiation of x in both the places. Now I can take it outside because x dy by dx plus y is common. I am taking it out. Therefore, I got it now. Now product of two terms are 0. Therefore, one of them is 0 or both of them 0. But here in the question it is given that tan xy not equal to 1. Therefore, sin xy by cos xy not equal to 1. For sin xy not equal to cos xy. Therefore, sin xy minus cos xy is not equal to 0. Therefore, when it is not 0, which should be 0 now? X dy by dx plus y should be 0. Therefore, x dy by dx is minus y. Therefore, dy by dx is equal to minus y upon x. Fine. Let us go to the next question. X cos y plus x square is tan inverse y. It is a total implicit function problem. Find dy by dx. Left hand side use uv formula. Keep x, differentiate cos y. Cos y keep and differentiate x. Differentiation of x square is 2x. Differentiation of tan inverse y is 1 upon 1 plus y square into differentiation of y. Or I got differentiation of cos y is minus sin y into dy by dx plus cos y, differentiation of x is 1. And I have collected dy by dx to one side, and on the right hand side I have kept it minus 2x plus cos y. Therefore, I am able to write what is dy by dx by cancelling that minus sign. 1 plus y square into 2x plus cos y upon x sin y into 1 plus y square plus 1. Thank you. Success is dependent on efforts. All the best. Thank you.